Hello students, today we'll discuss the assignment number 4 on set theory. Okay, so here you have your first question. Question is what? You have universal set, set A, set B, set C. Then you have to find A complement. Okay, first point is what? First part is you have to find A complement. A complement means collection of all the elements which is in universal but not in A. So you can say first part where you have to calculate your complement of set A, that is what? Sir, we have 1 2 3 4 in A, so we have to write all the elements of universal set which is not in A. So that is 5 6 7 8 and 9. Okay, so this is 5 6 7 8 9. Got it? 5 6 7 8 9. Next one, second is B complement. So B complement is what? B complement is, so in B we have 2 4 6 8. So B complement is 1 3 5 7 and 9. Okay, next is what? Next is A union C complement. So for the third part, first of all calculate A union C. So third is what? Third is first of all calculate A union C. So A union C is what? A union C is 1 2 3 4 5 and 6. Yes, 1 2 3 4 5 and 6. So A union C complement is what? A union C complement is equal to, that is 7 8 and 9. Okay, that is 7 8 and 9. Okay, this is what? This is your A union C complement. Got it? Now part number 4 is, for the part number 4, you have to calculate what? You have to calculate A union B whole complement. So A union B is what? A union B is 1 2 3 4. Okay, 6 and 8. 1 2 3 4. A union B is equal to 1 2 3 4 6 and 8. Okay, so complement is what? Complement is equal to 5 7 and 9. Got it? So A union B is what? A union B is 1 2 3 4 6 and 8. So complement is what? 5 7 and 9. So this is your A union B complement. Next thing is what? Fifth part is A complement, and we already know A complement is what? That is the set A. So fifth part is 1 2 3 4. So answer for the fifth part is, that is complement of A complement, that is equal to set A, which is 1 2 3 and 4. Now the last part is sixth part, which is, sir, B minus C complement. So B minus C is what? Collection of elements which is in B but not in C. So you have to remove 4. Okay, B minus C is what? 4 and 6. So in B minus C you have 2 and 8. Okay, B minus C is 2 and 8. So B minus C is equal to 8, 2 8. So B minus C complement is what? That complement is 1 3 4 5 6 7 and 9. Okay, this is the answer. Okay, so this is your question number 1. Now let's do the next question, question number 2. So question is, if A is equal to minus 4 to 1 semi-open semi-closed interval, B is 0 to 3 semi-open semi-closed interval, then find the following A intersection B and so on. So first of all, let's draw your number line. Let's say this is your real number line and you have minus 4 to 1. So minus 4 to 1, let's say minus 4 is somewhere here, minus 4. Okay, let's say 1 is somewhere here. So minus 4 to 1, minus 4 close, 1 open, minus 4 close and 1 open. Next is what? Next is B. So this is your set A set. Next set is the B set. B set is from 0 to 3. Let's say 0 is somewhere here and 3 is somewhere here. So 0 to 3, 0 close, 3 open. So 0 close and 3 open. Got it? So first is what? A intersection B. So first part is you have to calculate A intersection B. So this is what A intersection B means common part. Common part is what? Common part is here 0 to 1 open. 0 to 1 open. 0 close to 1 open. Second is what? Second is A union B. A union B is minus 4 to 3. A union B is equal to minus 4 close to 3 open. Okay. Next is A minus B. Third is A minus B. A minus B, that is which is in A but not in B. So A minus B is what? Minus 4 to 0 open. Okay. Minus 4 to 0 open. Got it? This is the portion which is in A but not in B. Okay. And 0 open. Why? Because 0 is in B set. Got it? So that is your B set. Yes. Okay. So minus 4 to 0, minus 4 close, 0 open. So this is A minus B. Next is B minus A. Fourth is B minus A. So B minus A is what? B which is not in A. Yes, collection of all the elements which is in B but not in A. So that is what? That is 1 close to 3 open. 1 close to 3 open. Okay. Fifth part is A union B whole complement. A union B whole complement, that is a real number minus collection of all real number minus A union B, and A union B is minus 4 to 3. Close interval minus 4 to 3. Okay. And the last part is sixth part. This is A intersection B whole complement. A intersection B whole complement, that is again R minus A intersection B, and A intersection B is 0 to 1. 0 close to 1 open. Okay. So these are the part of your second question. Okay. So now let's do the next one. Third is so here you have total 100 students. Yes, total number of students are 100. So 15 passed in English, 12 in mathematics, 8 in science, 6 in English and mathematics, 7 in maths and science, 4 in English and science, and 4 in all three. Find how many students passed, and we have different parts here. So let's draw the Venn diagram for this. So if you draw the Venn diagram, so situation is like this. So let's say this is my universal set, and in this universal set, how many elements we have? Sir, in the given universal set we have 100 elements. Number of element in universal set. Okay, you can say number of element in universal set, that is 100. Okay, total number of students 100. Now we have three different subsets of this, that is student who passed in English, who passed in maths, and who passed in science. So English, maths and science. So let's draw three circles here. English, for English, for maths, yes, for maths, and for science. Okay, for science. Got it? Now sir, we have data that 4 in all three. Yes, 4 students passed in all three subjects. So it means this is the portion where we have science student, where we have maths and English student. So who passed in all the three subjects? The number of students are 4. So write 4 here. This means number of students are here 4. Next is 4 in English and science. English and science 4. English and science 4. So you already have 4. So in this portion you have 0 number of students. Yes. Next is what? Next is 7 in maths and science. 7 in maths and science. Maths and science. Total number of students 7. Maths and science. So total number of students are 7 in maths and science. So 4 already have. So 3 you have to add 3 more. 4 and 3 7. Next is 6 in English and maths. 6 in English and maths. 6 in English and maths. So 4 and 2. Yes. Now next is 8 in science, 12 in maths. 8 in science. So total 437 now in your science. So 1 is here, 8. Okay, and 12 in maths and 15 in English. 12 in maths. So 3 is here. Yes, total number is 12 now. And 15 in English. 4 to 6. 15 minus 6 is 9. 9 is here. Okay. So these are what? These are the number of students in different portion. 9 means who passed only in English. 3 who passed only in maths. 1 who passed only in science. 2 who passed in English and maths. 4 in all three. 0 who passed in English and science. 3 who passed in science and maths. Yes. Okay. So now let's discuss your different parts. So first part is find how many students passed in English and maths but not in science. English and maths but not in science. English and maths but not in science. So this is the portion. Yes, this is the portion. This portion. Got it? English and maths but not in science. So how many students we have? Sir, 2. How many students we have? Sir, 2. How many students? Sir, 2. So answer for the first part is 2. Answer for the first part is 2. Yes. What about second one? Second part is, sir, in maths and science but not in English. Math and science. Math and science but not in English. So this one, this portion. Okay, so 3. Answer for the second one is 3. Next, third. In mathematics only, 3. 4. In more than one subject. So this is the portion. Yes, more than one subject. So this is the portion. Yes, more than one subject. Okay, that is 0 plus 2 plus 4 plus 3. 0 plus 2 plus, sorry, 0 plus 2 plus 4 plus 3. 0 plus 2 plus 4 plus 3. That is 9. So this is your answer. Yes, who passed in more than one subject. Okay, more than one subject. So this is the portion for more than one subject. Okay, 437 to 9 plus 0 is 9. That's the final answer. So this is your question number 3. Now let's do the next one. Next question. Next question is, so find the total number of integers n such that n lies between 2 to 2000. Both are in your, you can take both the values 2 and 2000 also, and HCF of n and 36 is 1. Okay, HCF of 36 and n is 1. So it means if you calculate 36 and find the prime factorization for this, so prime factorization is 2 2s are 4, 4 3s are 12, 12 3s are 36. So that is 2 power 2, 3 power 2. Okay, so you have to find such that number n such that HCF with 36 is 1. Okay, so you have what? You have to find some number n such that n 36, if you take the HCF of n and 36, that is 1. It means what? It means you have to find a number which is not divisible by 2 and 3. Yes, you have to find all the numbers between 2 to 2000 which are not divisible by 2 and 3. If your number is divisible by 2 and 3, yes, so you can say 2 or 3 actually, 2 or 3, then you can say the HCF is not equal to 1. Okay, so first of all, you can say number of natural numbers, number of integers between 2 to 2000 which are not divisible by 2 or 3, that is equal to total number between 2 and 2000 minus that is divisible by 2 or 3. Okay, so first of all find numbers which are divisible by 2 or 3. Got it? So we are calculating what? We are calculating here calculating number of integers, okay, calculating number of integers between 2 to 2000 which are divisible by 2 or 3. Okay, so how can you find the number of integers between 2 to 2000 which are divisible by 2 or 3? So you can say, sir, first of all find all the numbers which are divisible by 2, all are divisible by 3, and then subtract the integers which are divisible by 6. Yes, why? Because you count these numbers 2 times. Yes, you these numbers which are divisible by 6, yes, you have to remove them from your complete number of integers between 2 to 2000 which are divisible by 2 or 3. Okay, so first of all calculate, let's say, number, or first of all calculate number of integers which are divisible by 2, and they are what they are. So they are 2, 4, 6, 8 until 2000. So how many numbers we have in this set? This is here, this is what, this is the collection of all the numbers between 2 to 2000 such that they are divisible by 2. Let's say this set is A. So how many elements we have in your set? Number of element in A set, clearly we have 1000 elements. Yes, clearly you have 1000 elements. Now you have to find number of integers which are divisible by 3. Okay, calculate number of integers which are divisible by 3. Okay, got it? That is what? That is number of integers which are divisible by 3. So this collection contains what? This collection contains 3, 6, 9, 12 and so on till 1998. Yes or no? Got it? So let's say this is what, this is your set B which contains all the numbers divisible by 3. Let's say this is B. So if this is B, so now you can calculate number of element in your set B. That is basically this is AP, and you know last term is 1998, first term is 3, common difference is 3. Okay, so you can find number of terms here, that is 6, 6 and 6. So number of element in your B set is 666. But now if you observe, so in your A set and B set you have some common elements. These are what? These are 6 and next is 12 here. Yes, next is 12 here, 6, 12 and 18 and so on. Yes, 6, 12, 18 and so on. So it means you have to remove all the multiples of 6. Yes, because you have these multiples 2 times in your set A and set B. Yes or no? So it means now calculate number of integers which are divisible by 6, and these integers are 6, 12, 18 and so on. I think 1998. Yes, 1998. That is what? That is, yes, 333. Yes, 6 3s are 18, 1 6 3s are 18, 119 and 6 3s are 18 and 119. So this is, let's say this is what this is. Sir, this is A intersection B. Yes or no? This is what, this is your A intersection B, common elements in set A and set B. And you have to find what? You have to find, so find first of all number of element in A intersection B. A intersection B. That is what? That is 333. 333 elements. You have to find what? You have to find number of elements in A union B. Means number of elements, number of integers divisible by 2 or 3. We are calculating number of integers divisible by 2 or 3, that is equal to number of elements A in A union B, which is NA plus NB minus NA intersection B, which is equal to 1333. Got it? Now we have to find what? We have to find, sir, number of integers between 2 to 2000 such that which are not divisible by 2 or 3. So first of all, how many integers we have here? Sir, we have total 1999 integers. Yes. So total number of integers which are not divisible by 2 or 3. So you can say total minus, okay. So required answer is total 1999 minus, okay, numbers which are divisible by 2 or 3, that is 1333, which is equal to what? 666. So this is what? This is the final answer. Okay. Means what? Means how many numbers, how many integers we have between 2 to 2000 such that their HCF with 36 is what? 1. 36 with HCF with 36 is 1. So how many numbers we have, sir? 666. Got it? So now let's do the next question. Got it? So next is, so for set ABC using Venn diagram, check if A minus B minus C is equal to A minus B minus C or not. So let's take a Venn diagram here. So if you draw your Venn diagram, so for the left hand side, yes, for the left hand side, let's draw the Venn diagram for your left hand side. Left hand side of your equality is, let's say this is your universal set. If this is universal, draw your three sets A, B and C. So set A is here, set A, set B and set C. Okay, set A, B and C set. Okay, now you have to calculate B minus C. First of all, calculate B minus C. So B minus C is what? B minus C is this portion. B minus C. So this portion. This is B minus C. Yes, total B here. And if you eliminate your C elements, so you will get this B minus C. Yes, first of all calculate this B minus C. Now A minus of this set. A minus of this set is what? A minus of this set is, A minus this is this one. A minus this set. So A minus this set is this set. Okay, this is what? This is A minus of B minus C. Okay, that's your left hand side. Now if you calculate the right hand side using your Venn diagram RHS, so this is what? This is, let's draw your universal set first of all. Let's say this is the universal. This is A set, B set and C set. This is A, B and C. Okay, A, B and C. Now first of all calculate A minus B here. Yes, A minus B. So A minus B is what? A which is not in B. So A minus B is this one. Okay, or let's use your A minus B. A minus B means A this is A and eliminate all the elements of B. So A minus B. Okay. Okay, sir, no problem. Now you have to remove C also. Yes, A minus B. Now eliminate all the elements of C. So if you remove all the elements of C, then you will get what? You will get this thing. A minus B is this. Yes. Now elements of C also. Remove element of C also. So these elements are all eliminate. So if you remove all these elements, so your portion is this one. Remaining portion is this one. Okay, so this red portion is what? The required right hand side. So are they equal? No, clearly they are not equal. Yes, so from here you can say, using your Venn diagram, you can say A minus B minus C is not equal to A minus B and then minus C. They are not equal to each other. Got it? So this is the answer. Now next question is, for any two set A and B, prove that A intersection A union B dash is 5. So let's take the help of your Venn diagram. Okay, this is universal set. This is set A. This is set B. Okay, set A and B set. So A union B dash. A union B dash is what? A union B dash. So this is A union B. So A union B dash is this one. A union B dash is this part. This portion is what? This portion is A union B dash. Okay, this portion is A union B and its complement. A union B whole complement. And A is what? A is this one. A is this one. Okay, so A set is this. A set, complete set A, and the black portion is what? That is your A union B dash. So do you have something common in between them? Nothing. So it means A intersection, you can say from here clearly you can say A intersection A union B dash. A intersection A union B whole complement is equal to what? That's an empty set. Okay, proof using your Venn diagram. Okay, using Venn diagram. Using Venn diagram. Okay, that's your method number 1. Method number 1. Next is what? Method number 2. That is, Sir, we already know if you have to show two sets are equal, then you have to show one is subset of the other and the second set is also the subset of the first one. Okay. So method number 2 says, we already know, sir, what? Phi is what? Phi is subset of any set. So phi is subset of A. Okay. Phi is subset of A union B whole complement. A union B whole complement. Okay. Phi is what? Empty set is subset of any set. So empty set is subset of A set. Okay. And empty set is subset of A union B whole complement. So if this is subset of this and this phi is subset of the second set also, it means that is subset of their intersection also. Yes. So from here you can say phi is subset of A intersection A union B whole complement. Okay. Phi is subset of A intersection, phi is subset of A intersection A union B whole complement. Yes. Now you have to show that this is also the subset of phi. So now sir, let x be an arbitrary element of A intersection A union B whole complement. Yes, x belongs to A intersection A union B whole complement. So it means what? It means x belongs to A and x belongs to A union B complement. Yes. So from here you can say what? If x belongs to A and x also belongs to A union B whole complement, so it means x does not belongs to A. Okay. It means what? X does not belong to A set. Why? Because, sir, if x belongs to A, then x also belongs to A union B. Okay. So let's discuss here. If x belongs to A, then x also belongs to the union. Okay. So that's why if x belongs to A union B, so it means what? X does not belong to its complement. If x is in A, then we know x belongs to A union B. And if x is in A union B, then x is not the member of A union B whole complement. And here we know x belongs to A union B complement. So it means x is not the member of A union B. So it means x is not belongs to a set A. Okay. So now here x belongs to A and x does not belongs to A. It means what? X belongs to empty set. Okay. X belongs to empty set. If x belongs to empty set and this is the arbitrary member of this set, so from here you can say what? You can say A intersection A union B whole complement is subset of phi. So from these two, one and second, you can say what? You can say from 1 and 2, we can say A intersection A union B whole complement. A intersection A union B whole complement is equal to phi. Okay, A intersection A union B whole complement is equal to phi. That's your final answer. Okay, so these are two different methods. Got it? Now let's do the next one. Next is let A and B two sets such that A is equal to 20. Number of elements in A are 20. A union B is 42 and A intersection B is 4. So from here, let's draw the Venn diagram. This is the scenario. A and B. Okay, A set and B set. So A intersection B contains 4 elements. So total number of common elements are 4. Next, Na is 20, so 4 we already have in A, so remainings are 16. Now A union B contains 42 elements, so 16 and 4, 20 already we have, so it means we have 22 elements here. Yes. So sir, we have to find what? N of B minus A, number of element in B minus A. So this is the portion B minus A. So how many elements we have? So sir, number of elements in B minus A is equal to 22. So 22, that's the answer. Got it? Now next thing. Next question is here. So you have set A, set B, set C, and you have to verify the given result. So first of all, what is B delta C? Okay, let's say if you have P delta Q, so what it means? P delta Q means P delta Q set. Meaning of this is P minus Q union Q minus P. Okay. Okay. What is this? P delta Q. If you have two sets P and Q, so P delta Q is equal to P minus Q union Q minus P. Okay. So now calculate the left hand side. So left hand side is left hand side. So first of all, calculate B delta C. So B delta C. Okay, for left hand side. Okay, for the left hand side. For left hand side, calculate B delta C, that is B minus C union C minus B. So B minus C is what? B minus C. B minus C is 2, 3, yeah, 2, 3. B minus C is 2, 3. Union C minus B. C minus B is 4 and 7. 4 and 7. So this is equal to what? This is equal to 2, 3, 4 and 7. Now take the intersection of this. A intersection B delta C. So this thing is what? In A you have 1, 2, 4, 5. So you will get intersection as 2 and 4. Yes. So 2 and 4. This is in your intersection. Okay. So this is what? This is the left hand side. Got it? Now let's calculate the right hand side of your given result. So right hand side is, for right hand side. For right hand side, you have to calculate A intersection B first. A intersection B is A intersection B. That is 2 and 5. Yes, 2, 5. 2, 5. Next is calculate A intersection C. A intersection C. So A intersection C is what? A intersection C is, sir, 4 and 5. Yes, 4 and 5. Got it? Okay, no problem. Next. So sir, you have to find now A intersection B. A intersection B delta A intersection C. A intersection C. This is known as symmetric difference. Yes, this is known as symmetric difference. A intersection C. So this thing is what? A intersection B minus A intersection C. So A intersection B minus A intersection C is 2. That's 2. Union A intersection C minus A intersection B. That is 4. So this thing is what? This thing is 2, 4. Okay. So if you observe, both the things are equal for this. Yes. So from here you can say, from here we can say left hand side is equal to right hand side. Hence verified. Yes. So here you have some sets and you have to verify the result, given result. So this is the verification. Okay. Now let's do the next one. Next question. For any two sets of A and B, prove that if B complement is subset of A complement, then it implies A is subset of B. Okay, so you have to show A is a subset of B. Okay, so let X be an arbitrary element of A. Let X is any element of A. If X is any element of A, then it means what? X is not the member of A complement. That's the definition. Okay, and we know A subset is what? A subset, sorry, complement of A is what? That is, complement of A is superset of complement of B. So if something is not in A complement, that is not the part of B complement. Yes, so from here you can say X does not belong to B complement also. So if X does not belongs to B complement, so it means X belongs to B. So if you observe, X is what? X is any arbitrary element of A, and that is also in your B. So it means A is subset of B. Got it? A is what? A is subset of B, and this is what? This is the proof of given question. Okay, now next question is, so sir, in a survey of 100 persons, it was found that 28 read magazine A, 30 read magazine B, 42 read magazine C. So let's do this question again using your Venn diagram. So sir, first of all, draw the universal set. So in this universal set, how many elements we have? Sir, 100. We have total 100, survey of 100 persons. So now draw three sets. Set 1, this is what? This is collection of all the persons who read magazine A. Set B for magazine B. Okay, that set is for set who read magazine B, and this is who read magazine C. Okay, let's the naming of these sets are A, B and C. Okay, so now according to the data, 3 read all the 3 magazines. So 3 is here. 3 read all the 3 magazines. Okay, now 5 read B and C. So B and C. So it means 2 is here. Who read B and C but not A. Okay, next is what? A and C. 10 read magazine A and C. That is A and C. Yeah, A and C. So 7 is here. Next, for A and B, 8. That is 5 here. Okay, next 28 read magazine A. So 13 is here. Yes. Yeah. 30 read magazine B. So 20 is here. Next, 42 read magazine C. That is 30 read magazine C only. Okay. So this is your Venn diagram according to the given data. Now you have to find the how many read none of the 3 magazine. None of the 3 magazine. So it means you have to first of all calculate number of persons who read at least one of the magazine, and then subtract this data from the total number of person in your survey. Yes, total number of persons in your survey. So first of all calculate n of A union B union C. N of A union B union C. NA union B union C is what? So this thing is, if you calculate this thing from your given data, given Venn diagram, so you will get NA union B union C is 13 plus 5 plus 3 plus 7. 13 plus 5 plus 3 plus 7. 20 plus 2 plus 30. 20 plus 2 plus 30. So this thing is what? This thing is, this is 8. 8 and 2, 10. 10 and 20, 30. 30, 30, 60. 60 and 20, that's 80. So number of element in A union B union C is 80. So it means we have 80 persons who read at least one magazine. At least one. So you have to find what? Who read, number of persons who read none of 3 magazine, none of the 3 magazines. So that is what required thing is. Required answer is, so total minus who read at least one magazine. Yes, 80, that is 20. So this is the required answer. Got it? So that's your question number 10. Now next is your single correct MCQs. Okay, so you have what? In a city, 20% of the population travel by a car, 50% travel by bus, and 10% travel by both car and bus. Okay, so the person traveling by a car or a bus is what? So here, for the simplicity, let us assume in that city you have only 100 people. 100 people. Yes, population of your city is 100. So travelers, basically, you can say total number of travelers, population who travels, that is what? 100. So you can say you have to find what? You have to find persons who travel by car or a bus. Okay, so let's say A set is what? A set is collection of persons who travels by car, that is 20%. So 20% of 100 is 20. So number of element in A set is 20. Number of element in your B set, B is what? B is set of persons who travels by bus, that is what? 50%. So 50% of 100 is 50. Okay, and you have what? You have N of A intersection B, means population who travels by bus and car, both bus and car, that is 10%. So 10% of 100 is 10. Okay, so now you have to find person traveling by car or a bus. It means you have to find N of A union B, that is NA plus NB minus NA intersection B, which is 60. Okay, NA union B is what? 60, and total population is what? 100. So that is how much percent? That is 60%. So final answer is C. Okay, final answer is C. Got it? Now next question is, F1 be the set of all parallelograms. Okay, F2 set of all rectangles. So we know that every rectangle is a parallelogram. So F2 is a subset of F1. F2 is a subset of F1. Now F3 is the set of rhombuses. So every rhombus is a parallelogram. So you can say F3 is subset of F1. Okay. Next, F4 the set of squares. So every square is a parallelogram. So you can say F4 is also the subset of F1. Yes, and F5 is set of trapezium. Okay, so you have to find that F1 may be equal to what? F1 is what? So F2 intersection F3? No. F2 intersection F3 is what? Rectangles and rhombuses. Yes, intersection. No, that's not the collection of all the parallelograms. Similarly for B, F2 union F3? No. Yes, you have parallelogram which are not rhombus or rectangles. So if you observe D, so sir, we know if A is subset of B, we know one data, that is what? Sir, we know if A is subset of B, then if A is subset of B, then what about A union B? Okay, A is subset of B means every element of A is in B. So A union B is what? A union B is B. Yes, if A is subset of B, so A union B is what? A union B is B. Okay, so using this, you can say F4 union F1 is what? F4 union F1. Sir, F4 is subset of F1. So okay, you can say this is what? This is F1. Next, F3 and F1 is what? F3 union F1. F3 is again subset of F1. So you can say this is F1. F2 union F1 is what? F2 union F1. F2 is subset of F1. So you can say this is F1. So D denotes what? D denotes F1. So F1 may equal to this one. D is the correct one. Okay. So now let's do the next question. For any two set A and B, A intersection A union B complement is what? So we already know the answer for this. Yes, from here. A intersection A union B dash. A intersection A union B dash. That is what? That is 5. Okay. So you already know the answer. That is C, 5. Yes, C is the answer. Okay. Next thing. So final answer is C, 5. Now next question. So next question is, A and B are two sets such that N is 70 and B is 60 and NA union B is 110. So you have to calculate N of A intersection B. So you know one formula, that is N of A union B, which is equal to NA plus NB minus N of A intersection B. So you know NA union B is what? NA union B is 110 is equal to NA is 70 plus NB, that is 60, minus NA intersection B. So you can calculate N of A intersection B from here, that is 70 plus 60, that is 130 minus 110, which is equal to 20. Okay, so number of element in A intersection B is 20. So final answer is D. Got it? So now let's do the next one. Okay, very important question. Okay, important question. So you have to you are given with what? You are given with A1, A2, A30 are the 30 sets, each having 5 elements. Okay, so it means cardinality of AI, that is equal to 5. Yes, you are given with what? You are given with that A1, A30 are 30 sets, each having 5 elements. So number of element in any AIth set, that is equal to 5 for all I is equal to 1, 2, 3 till 30. Okay, and B1, B2, B3 are n sets, each with 3 elements. So number of elements in Bj, that is equal to what? 3 for all j is equal to 1, 2 till n. We don't know what's the value of n. We have to calculate it. Okay. Now we are given with union of AI. Union of this data is important. Okay. You are given with union AI, I is equal to 1 to 30. If you take union of all these sets, union AI, I is equal to 1 to 30 means what? So you are given with this thing, that union I is equal to 1 to 30 AI is equal to J1 to N, J is equal to 1 to N, Bj is equal to S. Yes, meaning of this thing is what? Meaning of this thing is, sir, if you take union of 30 sets, A1 union A2 union A3 till union A30, this is equal to B1 union B2 union B3 till B2 union till Bn. That is equal to what? That is equal to S set. Okay, this is the meaning. Now, and each element of S belongs to exactly 10 of the AIs. You know, if you choose any element here, any x, that x belongs to 10 members of here, this portion. Yes, 10 AIs. If x is, for example, if x is here in S, then x is in A1, A2 till A10, let's say. Okay, in 10 sets, x must be in your 10 sets. of the AIs and exactly 9 of the B's, and in 9 B sets, okay, B1, B2, B3 till B9, let's say, okay. So you have to calculate n. So you can say, sir, if you assume here total number of elements are k, okay, let number of element in S is equal to some p, let's say, okay, let's say number of element in S is p. So number of element, if number of element in S set is p, so you can say this p is what? P, that number of element, let's say any element x is here, so that is in 10 sets of AI and 9 sets of BI. So you can say 10 times P according to the data, 10 times P is equal to what? 30 into 5. What is the 30 into 5? Sir, we have 30 AIs. Okay, 30 AIs and each having 5 elements. Okay, so total number of elements are 30 into 5. But sir, we have p number of elements here and every element is repeated in your 10 of the AIs. So it means 10 times p is equal to 30 into 5. Okay, means every element is repeated in your 10 sets. So 10p is equal to 30 into 5. So from here you can say p is equal to what? You can cancel this thing with 3. So p is equal to 15. Okay. And similarly for this is for what? This is for AI. Now for BJs, that is 9 times. Yes, your every element of S is repeated in 9 sets. Repeated in 9 sets. So 9 into P is equal to what? The number of sets are n into cardinality of one set is 3. Each set having the 3 elements. So 9 into P is equal to n into 3. So from here you can say n is equal to 3P. And P is what? P is 15. So that is 3 into 15. So n is what? N is equal to 45. Okay. So this 45 is the final answer. Got it? So final answer is C here, 45. Got it? Now the next question. So next question is from your revision portion. Okay. So let's do this one. The difference of squares of two numbers is 88. Okay, you have two numbers and difference of their square is 88. If the larger number is 5 less than twice the smaller number. So let smaller number is, let smaller number is x. So larger number will be 5 less than twice of the smaller number. 5 less than twice of the smaller number. So 2x minus 5. So the difference of squares is 88. So it means according to the given condition, 2x minus 5 whole square minus x square is equal to 88. So when you simplify it, you can say this is 4x square minus 20x plus 25 minus x square minus 88 is equal to 0. So from here you can say that is 3x square minus 20x and this is minus 63, yeah, minus 63 is equal to 0. Got it? 3x square minus 20x and minus 63 is equal to 0. Okay, then now you have to calculate what? You have to calculate the value of x. So x is, now calculate x. So x is equal to minus b plus minus under root b square minus 4ac, that's plus 4 into 3 into 63 divided by 2a, which is 6. So now if you calculate it, you will get what? 20 plus minus under root of something divided by 6, and this something is what? 12 into 63. 12 into 63 is 756. 756 plus 400 is 1156. Okay, and 1156 is 34 square. Yes, I think 34 square. You can calculate. 1156. Yeah, that's 34 square. So you can say x is what? From here you can say x is equal to 20 plus minus 34 by 6. So you have two values. One is what? 54 by 6, and second one is minus 14 by 6, which is minus 7 by 3 and 9. Okay. So sir, find two numbers. So if x is equal to 9, so you have situation. So one number is 9 and second one is 9 into 2 minus 5. So from here you can say two numbers are 9 and 13. Okay, 9 and 13. 9 and 13. Got it? And now next number is what? Minus 7 by 3. If one number is minus 7 by 3, if x is minus 7 by 3, so second number is 2 times, that is minus 14 by 3 minus 5. So this time this is minus 29 by 3. So but now this is not the larger number, so you have to reject this thing. Okay, so your final answer is 9 and 13. Got it? Now let's do the next one. Find the two consecutive odd positive integers. Let's say one is x, so second is x plus 2. Sum of whose square is 970. So you can say x plus 2 whole square plus x square is equal to 970. So when you simplify it, you will get what? X square plus 4x plus 4 plus x square minus 970 is equal to 0. So from here you can say 2x square plus 4x, 2x square plus 4x minus 966 is equal to 0. Now divide by 2, you will get x square plus 2x minus 4, 8 and 3 is equal to 0. So now you can say this is x plus 23 and x minus 21 is equal to 0. Yes, that is x square 23x minus 21x, which is plus 2x, and 23 into 21, you can calculate the value. 23 into 21, that is 3, 2 into 4, 6, that is 3, 8, 4, so 483. So 483. Yes, so you can say from here x is equal to minus 23 and x is equal to 21. So you have what? You have consecutive positive, odd positive integers. So you have to reject this one. So x is 21. So your two numbers are 21 and 21 plus 2, that's 23. This is the answer. Okay. Now next question is, the difference of two natural number is 3. Let's say one is x and next is x minus 3. I'm assuming this is bigger than this one. Yes, so x is first natural number, let's say second one is x minus 3, and the difference of their reciprocal is 3 by 28. Okay, so if this is smaller number, so reciprocal is bigger than that. So 1 upon x minus 3 minus 1 upon x. Okay, these are the reciprocals, and the difference of their reciprocal is 3 by 28, and we are given with that is 3 by 28. So when you simplify it, you will get what? X minus 3 divided by x into x minus 3 is equal to 3 by 28. Okay, so you can say this is 3 upon x minus x is 0, minus minus plus, so 3 upon x square minus 3x is equal to 3 by 28. So when you compare, you will get what? You will get x square minus 3x is equal to 28. So from here you can say x square minus 3x minus 28 is equal to 0. So from here you can say x minus 7 into x plus 4 is equal to 0. Okay, that is x square minus 3x minus 28 is equal to 0. So from here you can say x has two values, x is equal to 7 or x is equal to minus 4, and we know x is what? We have two natural numbers, so x cannot be negative value, cannot take the negative value. So x is 7, so one is 7 and the another was 7 minus 3, that's 4. So this is the final answer. Okay, now next question is, the sum of the squares of two consecutive odd numbers. Sum of the squares of two consecutive odd numbers is 394. So let's say one is x, again another is x plus 2. Okay, so that is x square plus x plus 2 whole square, that is 394. Okay, when you simplify you will get 2x square plus 4x minus 390 is equal to 0. So from here you can say x square plus 2x minus, that is 195 is equal to 0. So you can say this is x plus 15 into x minus 13 is equal to 0. Yes, x square plus 2x minus 195. Okay, got it. So x can take two values, either x is minus 15 or x is equal to 13, and we know we have two consecutive odd numbers. Okay, so we'll take the positive values here. Yes, so if one is 13, so second number is 15, so 13 and 15 is your final answer. Got it? So this is the answer for your question number 19. Next one is what? Next is the last question of this assignment. Last question of this assignment. So solution is here. The sum of the squares of two consecutive multiples of 7. So let's say first multiple is 7 into x. So you have consecutive multiples, and next multiple is 7x plus 7. Okay. The sum of the squares of the two consecutive multiples of 7 is 637. So 7x plus 7 whole square plus 7x whole square is equal to 637. So when you simplify, you will get 49x square plus 98x, 49 plus 49x square minus 637 is equal to 0. So you can say 98x square plus 98x minus 588 is equal to 0. Okay, so when you divide by 98, you will get x square plus x minus, and 588 by 98 is, that is 6 is equal to 0. So from here you can say this is x plus 3, x minus 2 is equal to 0. Yes, x square plus x minus 6 is equal to 0. So you have two values, either x is equal to minus 3 and here you have x is equal to 2. Okay, again we are interested in positive values, so you cannot take minus 3 here. So x is equal to 2 because we are interested in the positive one. Okay, otherwise this is also the multiple. So answer is your numbers are 7 into 2, that's 14, and 14 plus 7 is 21. So this is the final answer. Okay, so that's the last question of your assignment number 4. So Now you can see all the videos of all the assignments, assignment number 1 to assignment number 4 on your set theory. Okay, in next video we'll discuss the assignment of another chapter. Till then, thank you everyone. Bye bye.